This video will go through an Excel tutorial where we can, given a set of data, we can create a scatter plot and graph the line of best fit using some Excel shortcuts. Find the correlation coefficient in the regression equation, and then find the residual and graph the residual plot. So let's start off with our Excel sheet and the set of data that we're going to work with. Here we have the number of years since 1990 and number of Starbucks stores. So in 1990 there were 84 Starbucks stores worldwide. 1995 there were 676. 2011 there's 4109, 4709, etc. So let's first make a scatter plot, and what I will do is I will highlight my two columns of data, and I will, in Excel, I will go to Insert, and under Charts I will click on the scatter plot, and I will select the one that has the plots of the data that's not connected. And here's my scatter plot. If you have a version of Excel that has quick layouts, you can click on that, and by choosing one of the layouts that looks like there's a line associated with it, we can select that and have our line data. So if you double click on that, again, this is a certain version of Excel, we have an option for our regression to be a linear regression versus an exponential, logarithmic, etc. So we'll choose linear for now, and I just want to change the color of my graph and make sure it's not dotted so that I can see it a little bit clearer. So this is step 1, or step 1 and 2, where we have the scatter plot and the regression line. The next step is setting up or finding our correlation coefficient. Now, our correlation coefficient is usually referred to as R. So I'll say R equals 2. To find our R, we're going to say equals, and then C-O-R-R-E-L is Correl, that's the correlation coefficient. And if I double click on that, it's going to ask me for two arrays, array 1 and array 2. It turns out that for the correlation coefficient, it does not matter which array comes first, the x values or the y values. So I will select the y value first, and I'll hit comma, and then I'll select the x values second, and I'll close the parentheses. Then that is going to be my values. If I tab or press return out of that, I have 0.93. That is pretty good correlation. Just on the side here, in case you missed it, I will have in green the actual command that I used to find this correlation coefficient. Okay, the next step is to find the regression line. So the regression line has a slope and a y-intercept. So to find my slope, I'll say equals and then slope. Again, the slope, if you double click on that option, it'll say slope, and it's going to ask you for two arrays again, but this time the y comes first, so that's important that you select the y first. So the known y's are there, comma, the known x's are here, and close the parentheses, and then you have your slope. So my slope here is 488.112. Now let's find our y-intercept, and for this I'll say equals, and then it's not y-intercept, it's just intercept. So click on intercept and select your known y's, comma, your known x's, close the parentheses, and then you have the y-intercept of negative 1105. So our equation will be the combination of x's and y's. So the way I would write this is I'll say y equals, and then normally I'd say y equals mx plus b, but remember in statistics we have a plus bx. So we'll say y equals the y-intercept, which is negative 1105.66. And then I'll say plus, and then 488 is the slope, 488.112 times x. So now that I have my equation, I'm ready to use this equation for my predictions. Okay, so I have my correlation coefficient and my equation. So let's take our correlation coefficient and equation. This is good correlation, so it's good to use our equation to make our predictions. So our predictions will be using this line and putting in the x values into that line to get our predictions. And the way we're going to do that is we're going to use the same equation and put in the corresponding x values. So for my first one, I'll say equals, and then again this is negative 1105.66 plus 488.112. These are the values for the slope and the y-intercept, times. Now instead of x, the first one is 0. And instead of me typing 0, what I'm going to do is I'm going to click on this 0. And so this is going to compute this formula by putting a 0 in place of this times, and that comes after this times. So if I press enter, I should get negative 1105.66 because 0 times 488 is 0, and you're not adding anything to 1105.66. Now, if I want this to go on as a formula, I would click back over here at my first prediction. I'll move my cursor to the bottom right corner until it's a little black cross, and then I will click and drag down. And so what this is going to do is going to copy the formula. Like if I click on this fourth one over here, or fifth one, I'll see that it's negative 1105.66 plus 48.112 times A6, which is this spot right here. And I can do that for all of those values to get my prediction. Okay, now I have my predicted values for each of these x values. The next step is to find the residuals. And the residuals is really just the difference between the y values minus the predicted values. So I'll say equals, and I'll press on the y value here, minus the x value here, and I'll press enter. So that's my first residual. What is a residual? The residual is really the distance, the vertical distance between the point in the data and the line right above or below that point. And it's a vertical distance, so we're really just subtracting a couple of y values. We can think about the predicted values as the y values from the line, and we can think about the y values from the point as the y value. Okay, same click and drag business. That will give you the rest of the residuals. Okay, so now we have the residuals. We're ready to plot the residuals. The residual plot uses the same x values and plots the residuals. So what I'm going to do is I'm going to highlight the x values, and I can include the header if I want, or not, it doesn't matter. So I'm going to include it here. Now I want to highlight another set of values that are not next to it. And to do that in Excel, I need to hit Control. I have my Control button down, and then now I'm going to click and drag all the values that I want highlighted. So now I have the years since 1990 highlighted, as well as the residuals highlighted, and they're not next to each other. Now that I have those, I will again select Insert, and in the charts I will select the scatter, and this is my scatter plot. Just change the colors real quick. So my scatter plot looks like this. And what would be cool to look at is compare the scatter plot with the residual plot. So what's happening here is that for each of these dots that I have, take a look at this line. We can think of these dots to the left of that line as being above the line, and then these dots over here are below the line, and then these dots up here are above the line again. Now we got 3 dots above and a bunch of dots below, and then another 3 dots above. If we look at the residual plot, we have these 3 dots that are above the x-axis, and then another 3 dots that are above the x-axis towards the end, and then these dots down below. Now that's exactly what's happening. Imagine taking your line and tilting it so that it's horizontal. And that's what's happening to our residual plots. So the idea is that if the residual plots are pretty close to the x-axis, then we have a pretty good line of best fit. And in this case we do. But the best way to analyze the line of best fit to see if it is actually in fact a good line is to look at your correlation coefficient. And if you have a correlation coefficient that's very close to 1, like 0.93 is, then that says that we have a good line that would fit our data. Alright, so scatter plot, correlation coefficient, equation of the line, the residuals, and the residual plot are all here. Okay, so I hope that helps in helping us remember how to work with these scatter plots and residuals. I'll talk to you next time.